The first one we will be discussing is the logic type. So in Verilog we have two popular constructs called as reg and wire. So when to use reg and when to use wire. Reg is used in procedural blocks such as always, initial, task and functional blocks. Like in Verilog, this classic reg is used to drive continuous assignments, gates and certain modules in addition to being an variable. So it can be used as a signal to store values that changes over time. And there is one more construct which is called as wire. Wire is used to connect different circuits. Like if you have a gate, if you want to connect one gate to the other gate, then in that case you can use wire possibly. And it can be used as a signal that connects different modules or is assigned by a continuous assignment. Now these two constructs were replaced by a construct called as logic in systemverilog. So in place of reg and both wire, you can use logic in systemverilog. But one drawback or one setback that this logic is having is it cannot support multiple driver. Let's say you have you need to model a bidirectional bus. In this case, the variable need to be wire rather than logic, because you need to drive multiple drivers. In this case, you need to have multiple assignments to a single variable. So in such case, logic cannot be a solution. So we'll be using wire in that case. So here you can see it is a simple example of like you have procedural assignment. We will be seeing in our upcoming lectures like what is continuous assignment and procedural assignment. So whatever you write in this block, it can be comes under a procedural assignment. So it can be used, this logic type can be used to drive these statements, and continuous assignment can also be derived, and a gate can be driven, a module can be driven by an logic type. So logic, these variables are declared using logic. So you can drive all these variables, you can drive all these constructs using this logic type. Now we will see how a logic cannot drive multiple drivers in this demo. So I am naming the module as multiple drivers. Let's declare a variable as logic A. This is declaration. And let me assign value of A equal to, here I am assigning just a 1-bit value which is 0, and let's try to assign one more value to A as well. Now I am trying to modify the assigned value of, like, in this is the first driver and this one is the second driver. Let's try to display the value of A and let's see what happens. Here I am mentioning it in a initial begin block. For now, just try to follow through. Just I'll in upcoming lectures I'll say what this initial block and all those stuff. Mention the format specifier. I'm trying to print A. As I have opened the initial block, I need to end it. And module. Let's try to run and see this output. So here you can see variable A has more than one continuous driver. Suppress this error and failure. So clearly you can see that there is a compilation error while you try to drive multiple drivers using this logic data type. Now let's try to modify this logic to wire and see the changes. So I am changing logic to a logic a to wire a, and just try to run this thing. Now you can see there is successful of the simulation. You will not able you are not encountering any issues. The value is assigned to a. So this is the change we can see when we need to. So you can use the logic type to find netlist bugs, as this type can only have a single driver. Rather than trying to choose between reg and wire, declare all your signals as logic, and you will get a compilation error if you try to have multiple drivers. Of course, any signal that you don't want to have multiple drivers, such as bidirectional bus, etc., should be declared with a net type such as wire. Okay.